Okay? Right, so first thing, full series, and the first thing we're going to look at is factorising. So, in your normal A-level, most of the time you are not going to have to factorise, you're not having to think about it the same way. You've got your calculators, in stats, mechanics, if ever you had to factorise a quadratic, you would just assume that you could put it in your calculator unless it showed detailed reasoning. Elements of this topic are going to ask you to give your answer in what we call a fully factorised form. And that literally means that you have got to factorise your answer as simply as it could possibly be. If you cast your mind back to the algebra test, there was a question on the algebra test, I think, I can't remember, it's not 10, let's make it 100 v squared minus 9u squared. And you are asked to factorise that fully. So look, I'm trying to think, it maybe wouldn't even be that. Let's think of something that where we would have like 100 u squared minus 36 v squared. Right, that's a bit better. So, some students will take out factor of 4. So you've got 25u squared minus 9v squared, which is what we would call partially factorised. They've done nothing incorrect, but they haven't factorised it fully. So what they're really looking for you to do here is to factorise it as simply as you possibly can. So Joe Plum, how could you, don't worry Joe, I don't think this bit's in the video, that's the bit that's in the video. How could you factorise that fully?
5e minus 3v, 5e plus 3v.
Okay, I think I've written it. I think my V's, I'm struggling with my V's and U's there, and I think I might have written it in the wrong way round to what you said, but that would be absolutely right. So we would say that this is partially factorised, this is fully factorised, okay? So nothing that challenging. So this will be at the end of a question. We're going to meet some new formulae to do with summation. Those formulae will have been proved by our new bit of proof by induction, which is reasonably straightforward. So the sort of thing that you're going to have to fully factorise are expressions that look like this. And they are expressions. They are not equal to anything. So you can't start dividing or multiplying. All you can do is actually factorise. So this is an example if you'd like to write it down. Bear in mind, it's probably one of the nicest, easiest things that you've done in maths for a while. So I'm going to give you the expression n plus 1 plus n squared over 3 bracket 2n plus 1 n plus 1. So what's happened is you've done some work, that's an n squared by the way, that little symbol there. You've done some work and you have ended up with that expression. And you are required to give a fully factorised answer. So you are going to write that as a single term. Right, Tom, what common factors can I take out?
N.
I can take out n, good, what else?
N squared is 1.
I can take out an n. Why can't I take out an n squared?
Well, you could do, because
Yeah, but it's not the way forward, is it?
Oh, okay.
The reason I don't want to take out an n squared is because I don't really have a factor of n squared here.
Oh, okay.
And if you expanded that bracket, you would have ended up with like single terms where you certainly couldn't take out. Yeah, you'd end up with an ugly fraction. Right, so what else can I take a common factor out of, please? n plus 1. And you see, I think that you're going to find that absolutely straightforward. I think the thing that causes most problems are fractions. So I'm also going to take out a factor of a third. Yeah, because I don't want any fractions in there, so I'm going to take out a factor of a third, so it's up to you whether you decide you're going to keep it. You could write it as n over 3 or you could write it as a third. So what you're now going to do is divide each of those terms by what you've taken out a common factor of. So obviously you're dividing n by n plus 1 by n plus 1, that's just going to be 1, but you've taken out a factor of a third, so that is going to leave you with 3 there. Okay, so I would say definitely it's the numbers where mistakes are made. And here you've taken out the third, you've taken out an n, and you've taken out an n plus 1. So you will be left with that expression. Is that clear? That's not quite neat enough. There is a possibility that if we expand this, we might be able to factorise it. I don't think we can here, but you won't leave it like that. You will then rewrite it, and you're going to have 2n squared plus n plus 3. You'll then think about whether that quadratic could be factorised. You could check it by putting it in your calculator. You can't factorise that expression. So you have taken 2 terms and you have written it in a fully factorised term. Is that clear? And I'll just do one more. So with 2, we'll do exactly the same. We've got 2/3 n plus 1. Plus a quarter n squared n plus 1 plus n. So again, we've now got 3 terms added together, and I'd like you to write that in a fully factorised form. So, Tom, I've just picked on you, sorry, let's go to Harry. What can you take a factor out of? N. Okay, so it's not great, but I am not enjoying the fractions, which is really why we're doing this example. I don't want those left there. I don't want fractional terms in there. So Harry, what can I take a factor of that will sort those rather unpleasant looking fractions? Good, you would take out 12. And that's because that can be written as 3/12, and that you can write that as 8/12. So you might want to visualise what 2/3 and a quarter look like as 12ths. You could change them. You know a quarter is going to be 3/12, and you know that your 2/3 is going to be 8/12. So that's maybe more easy to visualise. So I'm going to this time write that as n over 12. So I suppose all you're doing is you think that when you divide by a 12th, it's like multiplying by 12, isn't it? So is that going to be, if you've taken out a factor of 12, so if you think multiplying that by 12, are you going to get 8? Check that please. If I multiply that by a 12, I've got 2/3. And here, if I multiply that by 12, I have 3n plus 1. And then lastly, I've taken out the n, which leaves me with a 1 and a 12. So that last term will be 12. If you are unsure, visualise how that will expand. So you're now going to sort out what's inside that square bracket. 8n plus 8 plus 3n squared plus 3n plus 12. I don't know if it's going to go anywhere good. Let's have a little look. n over 12. So you're going to have 3n squared. You've got 11n plus 20. And then what you could do is you can put it in your
calculated to see if it factorises.
I don't think it does. So if you have a quick look, 3n and 20, so you could have 5 and 4, that's not going to work. You could have 2 and 10, it's not going to work. 1 and 20, I'm pretty sure that doesn't factorise. Any questions?